A pharmaceutical company is researching a new treatment for a specific disease by adding material M to a petri dish filled with diseased cells. After the material is added, readings are taken at intervals to monitor the number of diseased cells, denoted as C, in relation to the weight of the material M. This sounds very exciting. The head of the research team has determined that the rate at which C is decreasing with respect to M is directly proportional to the natural logarithm of the square of M. Which of the following equations could describe this relationship? All right, well, we've got first off, rate. Weight with respect to M, rate of C with respect to M is this. They care about when C is decreasing, so it's going to be negative. Since it's directly proportional, keep in mind directly proportional is usually in this form. You learned that back in Algebra 1. So we're going to have some arbitrary k, and it's to the natural logarithm of the square of m. So negative k ln of m squared. Which, if you wanted to, you could take it one step further and rip that 2 out, but it looks like they don't need you to. It looks like right off the bat we have our guy, and it's going to be C. Kind of a weird problem. Lots more reading than doing, but we did it. Given that f of t represents the position of a car as a function of t, where t is the time in minutes since the car started moving, which of the following represents the velocity of the car? Well, if you're given a position function, the velocity function is just going to be the derivative of the position function, and the answer is C. So thank you for watching. I hope you guys had a really good time. Don't forget to like and subscribe. If S of t is a baby's shoe size at time t, which of the following differential equations describes linear growth in the size of the baby's shoes? So you're given a bunch of ds dt's here. Remember, ds dt stands for slope. So ds dt is slope. In order for the actual thing, the actual equation to be linear, the slope has to be constant, a regular number, like 5 or 12 or 2. So C is the answer because the rate of change needs to be a constant in order for it to be linear. The maximum safe load for a horizontal beam of fixed width changes depending on the length L of the beam. So we have ds dl happening here. The load S decreases with respect to L and is proportional to the product of its width and the square of its height, and inversely proportional to its length L. Which of the following differential equations model this relationship? So we got, it looks like 3 things that we're kind of looking at here. First things first, the load decreases with respect to L. Okay, so that's going to give us a negative going on here. Okay. Now, proportional relationships are given to you as the form y equals kx, right? This is telling me proportional to the product of its width and the square of its height, all right? So we're going to have a k, we're going to have a w, and its height squared. Now, if it's inversely proportional, you're going to divide that guy, so it's going to be inversely proportional to its length L. So when we have all of this stuff together, looks like C is going to be my answer. So kind of a grody looking problem, not so much fun, but yeah, that's how you do it.